Nitty-gritty. As mentioned previously, there's no definitive answer for what dark matter is, so it is difficult to understand it using conventional physics formulas. However, the expansion of our universe is measured using the formula P times a to the negative 3, where a is the scale factor. The scale factor is an abstract equation used to model the relative expansion of the universe, with a being dimensionless. From the equation above, we can see that the matter is defined on a technical level as anything that has a direct correlation and scales proportionately with the inverse cube of the scale factor, a. According to this, dark matter is thus anything that obeys the scale factor while also being invisible to the naked eye. Detection of dark matter. The concept of dark matter is still a hypothesis. There are numerous observations by leading scientists which would either partially or entirely refute this concept. Therefore, many scientists have attempted to detect dark matter, due to it being easier than deriving another set of equations or modifying Einstein's theory of relativity. Due to dark matter hypothetically occupying 27% of space, that would mean that billions of dark matter molecules will be passing through space around us every second. Thus, the challenge is not to find them, but to come up with a machine that can interact with the subatomic particles of which they are made of. The first category under which scientists could detect dark matter is direct detection. It involves observing the direct sequences of interactions between normal matter and dark matter. The main way of doing this so far is through cryogenic detectors. Most of you have probably heard of cryogenic chambers, which are chambers that athletes use in order to lower their body temperature to extremely low levels and thus repair their muscles. These detectors operate in a similar way. They freeze the air and lower it to negative 273 degrees Celsius, right below absolute zero. Since the area under detection is so cold, microscopic heat collisions can be detected between particles, and it is theorized that they could be used in order to detect dark matter interfering with other particles. Notable laboratories that are attempting this process include Deep Underground Science and Engineering Laboratory and China Jinping Underground Laboratory. The second way in which scientists could detect dark matter is through indirect detection, which involves looking for the after effects of interactions between dark matter and a similar or foreign substance. The possible ways in which you could detect dark matter through this method would be through decay, similar to radioactive decay, where the nucleus of the particle loses energy, or two dark matter molecules colliding and annihilating each other, creating an abnormal burst of energy that would be detectable. In conclusion, dark matter is a fascinating, yet often overlooked principle in physics. If true, and when discovered, it could be one of the most important moments in all of science. However, it is not unlikely that dark matter doesn't exist, as numerous detection devices have yet to correlate a cause with the source. Thank you for watching this video.